When a new main breaker panel is installed in a dwelling and some of the wires are 12 American wire gauge 2 conductor without a ground, the National Electrical Code (NEC) addresses these branch circuits. Section 404.11 addresses grounds for grounded systems. New branch circuits with a size of 12 American wire gauge or larger must have an equipment grounding conductor. Section 380.12 covers the grounding of receptacle outlets and grounding type devices. All 120-volt, single-phase, 15 and 20 ampere receptacles installed in non-industrial buildings must be grounding type or grounded. The electrician's responsibility is further defined in these NEC sections. Section 406.3 addresses the grounding and bonding of electrical equipment. The electrician is responsible for providing a proper ground for all electrical equipment and devices. This includes adding an equipment grounding conductor to existing circuits where one is not present. Section 404.2 discusses bonding, stating that the electrician must bond all metallic enclosures, frames, and other non-current carrying metal parts to the equipment grounding conductor. Section 406.7 covers receptacles in damp or wet locations. All receptacles in damp or wet locations must be of the grounding type and have ground fault circuit interrupter protection. In summary, for branch circuits with 12 American wire gauge 2 conductor wires without a ground, the NEC requires that the electrician add an equipment grounding conductor. The electrician is responsible for ensuring that all electrical equipment and devices on these circuits are properly grounded and bonded. This includes replacing or modifying any ungrounded receptacles or equipment to meet the current code requirements. The equipment grounding conductor provides a low impedance path for fault current to return to the source, facilitating the operation of the overcurrent protective device such as a circuit breaker or fuse to quickly clear the fault. This minimizes the risk of electrical shock and fire. Bonding ensures that all metallic parts are at the same electrical potential, further reducing the risk of shock. Ground fault circuit interrupter protection is crucial in damp or wet locations because these environments increase the risk of electrical shock. A ground fault circuit interrupter monitors the current flow into and from an appliance or device. If it detects an imbalance, indicating that current is leaking to ground, it quickly trips the circuit, cutting off the power and preventing a potentially fatal shock. When dealing with existing 12 American wire gauge 2 conductor circuits without a ground, several options may be available to the electrician to bring them into compliance with the NEC. Firstly, an equipment grounding conductor can be added to the existing circuit. This may involve running a separate ground wire from the panel to each outlet or device in the circuit. Secondly, the existing 2-wire receptacle can be replaced with a ground fault circuit interrupter receptacle. Ground fault circuit interrupter receptacles provide protection against ground faults, even if there is no equipment grounding conductor present. Thirdly, the circuit can be protected by a ground fault circuit interrupter circuit breaker in the panel. This provides ground fault circuit interrupter protection for the entire circuit. When selecting the appropriate method, the electrician should consider the specific circumstances of the installation, including the age and condition of the existing wiring, the location of the outlets or devices, and the presence of any other potential hazards. It is important to note that replacing a 2-wire receptacle with a 3-wire grounding type receptacle without providing an equipment grounding conductor is a violation of the NEC. This creates a false sense of security and does not provide adequate protection against electrical shock. The NEC also addresses the use of surge protective devices. Surge protected devices are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line disturbances. Surge protective devices should be properly grounded to function effectively. The NEC provides specific requirements for the installation and grounding of surge protective devices. In addition to the NEC, local codes and regulations may also apply to electrical installations. It is important to consult with the local authorities to ensure compliance with all applicable requirements. Proper grounding and bonding are essential for electrical safety. Failure to comply with the NEC and other applicable codes and regulations can result in serious injury or death. When working with electricity, it is always important to exercise caution and to follow safe work practices. This includes wearing appropriate personal protective equipment such as gloves and eye protection, and using properly insulated tools. It is also important to de-energize circuits before working on them and to verify that they are de-energized using a voltage tester. The NEC is a comprehensive set of standards that covers a wide range of electrical topics. It is updated every 3 years to reflect changes in technology and best practices. It is important for electricians to stay up to date on the latest version of the NEC to ensure that their work is in compliance with the current requirements. The NEC is available for purchase from the National Fire Protection Association, NFPA, and other sources. Many jurisdictions also make the NEC available online. Electricians should have a copy of the NEC available for reference when performing electrical work. The NEC is a valuable resource for ensuring electrical safety. By following the requirements of the NEC, electricians can help to protect themselves and others from the hazards of electricity. In addition to the topics already covered, the NEC also addresses the following electrical safety issues. Arc flash hazards. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates a high energy discharge. Arc flash can cause severe burns, blindness, and even death. The NEC requires that employers conduct arc flash hazard assessments and implement appropriate safety measures to protect employees from arc flash hazards. Electrical equipment labeling. The NEC requires that electrical equipment be labeled with specific information, such as voltage, current, and horsepower ratings. This information is important for selecting the correct equipment for a particular application and for ensuring that the equipment is properly installed and maintained. Electrical safety training. The NEC requires that employees who work with electricity receive adequate training in electrical safety. This training should cover topics such as the hazards of electricity, safe work practices, and the use of personal protective equipment. Lockout-tagout procedures. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. The NEC requires that employers develop and implement lockout-tagout procedures to protect employees from electrical hazards. Grounding electrode system. The grounding electrode system provides a path for fault current to return to the source. The NEC specifies the requirements for the grounding electrode system, including the type and size of grounding electrodes, and the methods for connecting the grounding electrodes to the electrical system. Overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. The NEC specifies the requirements for overcurrent protection, including the size and type of overcurrent protection devices, and the methods for installing and maintaining overcurrent protection devices. Wiring methods. The NEC specifies the acceptable wiring methods for different types of electrical installations. This includes the type of wire or cable to use, the methods for installing and supporting the wiring, and the requirements for protecting the wiring from damage. Electrical inspections. Electrical inspections are conducted to ensure that electrical installations are in compliance with the NEC and other applicable codes and regulations. Electrical inspections are typically performed by local authorities or by qualified third-party inspectors. Electrical safety is a shared responsibility. Electricians, employers, and homeowners all have a role to play in ensuring that electrical installations are safe and compliant with the NEC. By working together, we can reduce the risk of electrical accidents and injuries. When installing a new main breaker panel, it is crucial to consider the existing wiring and ensure that it meets current code requirements. This is especially important when dealing with older wiring systems that may not have an equipment grounding conductor. The electrician should carefully inspect the existing wiring and determine the best course of action to bring it into compliance with the NEC. This may involve adding an equipment grounding conductor to existing circuits, replacing ungrounded receptacles with ground fault circuit interrupter receptacles, or installing a ground fault circuit interrupter circuit breaker in the panel. In some cases, it may be necessary to replace the entire wiring system to ensure compliance with the NEC. This is a more expensive option, but it may be the safest and most reliable way to address the issue of ungrounded wiring. When replacing receptacles, it is important to use the correct type of receptacle for the application. For example, receptacles in damp or wet locations must be of the grounding type and have ground fault circuit interrupter protection. Receptacles in kitchens and bathrooms must also have ground fault circuit interrupter protection. The NEC provides specific requirements for the installation of receptacles in different locations. It is important to follow these requirements to ensure electrical safety. In addition to the NEC, local codes and regulations may also apply to receptacle installations. It is important to consult with the local authorities to ensure compliance with all applicable requirements. Proper receptacle installation is essential for electrical safety. Improperly installed receptacles can create a shock hazard or a fire hazard. When installing receptacles, it is important to follow safe work practices and to use properly insulated tools. It is also important to de-energize the circuit before working on it and to verify that it is de-energized using a voltage tester. The NEC is a complex and comprehensive document. It is important for electricians to have a thorough understanding of the NEC to ensure that their work is in compliance with the current requirements. Electricians should also stay up to date on the latest changes to the NEC. The NEC is updated every 3 years. Electricians can stay up to date on the latest changes to the NEC by attending training courses, reading industry publications, and consulting with other electricians. Electrical safety is a continuous process. It is important to regularly inspect electrical installations and to make any necessary repairs or upgrades to ensure that they are in compliance with NEC. Homeowners can also take steps to improve electrical safety in their homes. This includes checking receptacles for damage, replacing frayed or damaged cords, and avoiding overloading electrical circuits. By working together, electricians, employees, and homeowners can create a safer electrical environment for everyone. The information provided here is intended for general guidance only. It is not a substitute for professional electrical advice. If you have any questions or concerns about electrical safety, you should consult with a qualified electrician.